Hello guys, you're welcome back to our class again. In this class, we are bringing you the practical solution to the 2023 physics WAEC question for light. In this particular experiment, we are provided with a rectangular glass block, as you can see here, a drawing paper, and then a drawing board with a protractor, a meter rule, and optical pins, of course, a thumbtack to hold the paper. What is the experiment all about? Now, in this experiment, we are first of all told to measure the width of the rectangular glass block. You can see here is my rectangular glass block. So I'm asked to measure the width. So I'm going to check to measure the width of the rectangular glass block. If you check with me here, you will see that the width of the rectangular glass block is exactly 5 cm. So I'm going to record the width as 5 cm. After that, we are now asked to draw the outline of this block. So I'm going to draw the outline of this block, A, B, C, D, and then measure, label here A, B, C, and A, B, C, D, and then measure out a point Q, which is 1.5 cm from A. That is the point where I'm going to draw my normal. So let me measure out the outline, and then I will record and draw the normal. So here is the outline of my block on my paper. So the next instruction will be that for me to draw my normal, I would have to find out the distance. Here is where they asked us to put A, and here is B, and here is C, here is C here, and then finally we have D. Now I'm asked to find out a distance of 1.5 from point A. So anywhere I have 1.5, I'll mark it out, and then I'll find my normal at that point. So I'll just tap 1.5. Here is 1.5. So now that I have gotten my 1.5, I can find my normal at this 1.5. So let me draw my normal line. I'll come back. So here is my normal line on the block. So with this, now we are asked to find an angle of incidence, which is 10 cm from the normal. So I'm going to balance this and find 10 cm from the normal, and then I'll draw the line. Once you draw the line, just produce it at once with dotted line so that we don't have to do that at the end of the experiment. All right, so here's what we have. You can see our angle of incidence already measured. I produced along the block. So I've already recorded it here that I is equal to 10. Now I am going to fix 2 pins along this I here, and then when that is done, I will replace the block and then view from this other end and check out to see those 2 pins, and of course find out using another 2 pins the point where all the 4 pins will be aligned. And at that point, I will now join those 2 pins to the block, and we'll take it up from there. So let me fix up these 2 pins. So here is what we have at the end of the day. Here are the first 2 pins, P1 and P2, standing here along the line of incidence. Here is the block firmly replaced, and here are other 2 pins that we have used to replace the other pins. Now, if you check from the edge here, whether it is visible, you would see the pins. You can see them from here, from the edge here. Now, these 2 pins here are used to actually check the other pins. I'm putting it by the side here, you can see. Now, if I align them, just watch, you will see that all the points, all the pins are aligned together in a particular direction. So this is the point. So I'm going to now quickly connect this line to the block. Here is my final result. Haven't done that, so I've measured my R here, which is the angle of refraction here, using this angle from here to here, and it gave me 6.5 degrees. And then the distance D, according to the drawing you are seeing, is the distance from this point to this point. I measured that using my meter rule, and it gave me 0.3 centimeters. So this is actually the first expectation for us on this paper. There are other things that are expected for us to deduce: the tan of I, tan of R, and then V. So, but that would come up later in the table. Now I'm going to repeat this procedure for I, which is equal to 20, 30, 40, and 50. So stay tuned so that I will show you how the result came about. All right, the same procedure has been repeated here. First of all, I drew my normal and then found the angle of incidence to be equal to 20, and then I fixed in the 2 pins and then replaced the block viewed from this other end, and then you can also see it here that this is the pin from the other end. Now if you check, you will see that all of them are aligned at this point. This is the point where you see all of them are aligned. So here, now that we have gotten that point, I'm going to remove the pin and connect this pin to the block. And then I'll do the measurement for I and R and D. All right, so in order to speeding things up, here is what we have for our second. I is already given a standard value to be 20 degrees. By way of measurement, our R and our D both give us 12 degrees and 0.8 cm respectively. Now, I've also set up the third experiment here. You can see that here I is increasing. So we have I to be 30 degrees. 2 pins are already inserted, the block has been replaced, and the 2 pins has been used to replace the. So if you look at it from here, you will see that if you look at from here, you will see the 2 pins from the block. But as we approach here, you will see that both of them has been successfully blocked at this point. If you notice, you can see that they have been successfully blocked. Now, so this is what we have here. I'm going to still remove this and measure the distances and the angles before we move to the next one. Here is the reading of the third experiment. So we have I is equal to 30, R is 18, and D is 1.4. You can notice something common with this experiment. I is constant, of course, given to you 10, 20, 30. Here you have R to be 6.5, 0.3. The second one, you have this one, 12 and 0.8. And here you have this is 18 and 1.4. So let's be observing, and then at the end of the day, you will see how it looks like in the table. I've also set up the fourth experiment. In this experiment, you can see I've measured the angle to be I equal to 40, and then fix the 2 pins. I've already done the measurements here. You can see, let me still show you. So here, if you look very well from the edge of the block, you will see the other 2 pins from the other end. I'm watching it from the side. Now let's move towards where the pin is. Now observe, you will notice that at the pin part, you will notice that all of them are in a straight line. You see all of them are blocked. Now if I go past it, you will see the other pin from the other end. So it means here we have passed it. So here is the point where we have all the pins aligned together. So I'm going to remove all of this and then measure the required measurement, and then I'll proceed to the next one. All right, so here is our fourth reading here. I equal to 40, constant value given. Our R give us 24 degrees and our D give us 1.9 cm. Here also is our last setup. Remember, we have only 5, 1, 2, 3, 4, and then the fifth one, which is the 50 degrees for the I. This has already been measured. This is the first 2 pins that are inserted along the line of incidence. The block here has been replaced, and then 2 other pins has been used to block and replace them. Now, just for confirmation whether you will see it. So if you look through the block, once you look through the block, you're going to notice that you can see the 2 pins already disaligned. But here, as I approach the pins, you can see them here, that at this point now, all the pins are one. So here is the point where we have all of them as one. So you can see it is very clear and intact. So this gives us accurate result. So I'm going to remove these pins. All right, so here is the final outcome. You can see my last reading as I 50, R 29, and D 3.3 cm. So here are the readings. Now, if you notice something common with all this drawing, you notice that the incident ray produced is almost parallel, or would be parallel, with the emergent ray which it comes out. This is one of the ways you know that you are actually accurate. Once it begins to diverge in such a way that they are not as parallel as they should be, then it means that something is wrong with your readings and measurements. So taking this as my hint for accuracy, right? So this is my tracing paper, and this is the readings that I have got. So I am going to quickly put this in a tabular form, and then from there we can take it up to plot the graph, find the slope, and answer the sub-answer questions that follow through. Please stay tuned. Okay guys, having conducted the experiment, we are requested to plot a graph with D on the vertical axis and V on the horizontal axis, and then after that we'll be able to determine the slope S of the graph, while we'll also proceed to state 2 precautions that were taken to ensure good results during the experiment, plus some few short answer questions that were asked during the experiment. Now, we've done the experiment together already. Here is what the table looks like. You can see from this table that the angle of incidence I, the angle of refraction R, and the distance between E and F, as you saw in the drawing in CM, all was captured on the table. And then to drive it forward, they said we should find the tan of I and the tan of R, and to also compute V, which is the difference between tan I and tan R. All of this we have calculated using their various reading accuracies. So you can see that none of them was recorded to a whole number. So here is what the breakdown of the table actually represents. And it is with this table that we are going to proceed to plot the graph. And then recall that we are asked to plot a graph of D on the vertical axis and then V on the horizontal axis. So take a look at the graph. You can see that here it is a straight line graph that passes through the origin. I believe yours did as well. So if you check our scales, we are correctly selected. There wasn't any odd number values on our scale, and then you can see that the axes are also distinguished. A graph of D and against V, both are being distinguished in their various axes, and then you can see the traces on the graph. The trend line is also drawn to get the line of best fit, which you can see there, and then the slope line is also drawn to a large triangle. So with this, we are asked to find the slope. The slope would simply be the change in the D which was given to us, or which we deduced during the experiment, against, or the ratio of this D, change in D, to the ratio of the change in V. By the time we had taken our upper and the lower values for both and computed, our value gave us 5.148 centimeters. It is at this point that I'll now have to let you know the practical aim of this experiment. Now, the aim of this experiment is actually to determine the width of the rectangular glass block provided. You can even see it in the drawing that they emphasized that you measure the width of the block. Now, this is actually where you know how accurate or how close. Of course, it is not actually expected that we'll get 100% accuracy in conducting this experiment, because definitely there must be some experimental errors, maybe in the measurement of your protractor, in the viewing of your pins, and then in some other few experimental errors you may encounter. So at least it should be close to the actual value, with a percentage error not more than 10%. So let us see how accurate we are in conducting this experiment. Recall that earlier, while conducting the experiment, we stated that the width of our block is 5 cm, and now our slope has been deduced to be 5.148 cm. Now, this is how you know how accurate you've been in the experiment. Your slope value is actually meant to be the width of the block. Remember, I told you earlier that the experiment is to determine the width of the rectangular block that is provided. So if we check now the theory of this particular experiment, as you see here, is that on comparison with the slope of the graph, we found out that the percentage error for my experiment here is plus or minus 2.96%. Now it is not it is actually approximate. Okay, this is a fair enough value for a practical session, although it can be lower. And then actually this this arises due to some errors that results due to the deviation of the result, which included the mathematical errors in drawing of the graph, and then use of measuring instruments like the protractor, and some few experimental errors during the conduct of the experiment. So this is actually the major thing that you're actually expected to do in this particular experiment. And if you've gotten it right, then that means that you're very perfect. So compare your value of the width of your rectangular block and then compare it with your slope. That will tell you how accurate you've been in this particular experiment. Then finally, as we begin to wrap up, there are some precautions that we took in conducting this experiment. One of them was that we ensured the pins were vertically erect. I told you this while we were conducting the experiment. We also ensured neat traces. The pencils must be sharp while we were drawing our traces, and then we ensured reasonable spacing of the pin. Actually, standard spacing of the pin should be about 4 cm apart, and then avoid parallax error in reading the protractor and the meter rule, the half meter rule that was given to you. Then we're asked to state the condition for the occurrence of total internal reflection at glass air interface. Now, of course, this is very straightforward, because for light to undergo total internal reflection, that light must move from a more dense medium to a less dense medium, and then of course the angle of incidence must be greater than the critical angle. So once that is done, these are the conditions that are necessary for total internal reflection to occur. And then finally, we're asked to state Snell's law. This is one of the laws of refraction. It states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. This law can be represented using a mathematical statement of a refractive index is equal to the ratio of sine I to sine R, which we say is a constant. So if you have been able to state this accurately the way we have stated it here, then you are rest assured that you've done excellently well in this particular experiment. I will wish you all the best. So here is actually the summary of what we have for this particular experiment. Please do well to actually subscribe to our channel, share the video, like the video, and feel free to comment and ask questions. We will be there to clear you. Please stay tuned as we also unfold some of the videos that we have in store for you. God bless you. Have a nice day.